Okay. Uh, I'm not sure what is going on right now on the stream. Okay, just a oh. Hello, 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 hello. Sorry, 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 sorry. uh, okay, hello. I hope I am audible now. So yeah, hi, my name is Tushar, and I'm a freelance graphic designer and a web developer. I am in BTech second year, and we are building Store ENV, which is a platform where you can store your ENV or your environmental secrets. So this platform will be very similar to GitHub, but it will be a bit different too. Why? Because GitHub is a place where people can also use your repositories. So, but obviously, environmental secrets are a bit different than that. So that is one thing. And besides, I did a live stream day before yesterday in which we started building the encryption system. Not building exactly. We started. Uh, Hi, so stupid D. Hi, Sakura Samurai. Okay. So yeah, as I was saying, uh, yeah, so we started building the algorithm of store env, and today we are going to continue that. So yeah, let's start. First, let's kind of revise what is the flow of our uh, current store env. So let me open Excalidraw. Okay. Okay, just give me a minute. Okay, so our encryption system is like, yeah. So yeah, we can start now. So as I was saying, our encryption system starts something like this. Let's suppose you have an uh, this is your env file of a project A. I'm sorry, my writing is so bad. Hi, Herman. Uh, just give. Okay. So, uh, so let's suppose this is one of your env file of your project, and it consists of four environmental secrets. Okay, one, two, three, and four. So our system will be like this. You will type store env, uh, store env push. Okay. So what will it do? It will. Okay. What will it do? Uh, for some reason my pen is not working. Uh, I'm not sure why is this happening. Choose black, right? Okay, let me restart it. Uh, okay. So when we type store env on your on our terminal, what will it do? Uh, before before understanding the push command, we have to understand something else, which is our login system. Okay, because all of this will be connected. So when you type store env login, and when you sign up for the very first time, what will happen? Uh, the platform will generate you a 24 word uh, key, which will be for your recovery phase. This key will be this key will further give you a key, which will be your root key. Root key is like your DNA of your account. So if you somehow lost your data on your main laptop or your main device, this root key will help you to recover all of your data from uh, from our server. Okay, so this root key will be never exposed to anyone, and this key will further derive two keys, which is a public key and a private key. Okay, so now you might ask me, Tushar, why do we have to create two keys for this? We can. Hi, Daksh. So, so you might ask me, why do we need two keys if we can encrypt our secrets with just one? So I'll tell you that. Uh, okay. So your public key, as the name suggests, the public key is supposed to be public. It will be more of like your how your usernames work, like you exchange with your friends to connect with them. So it will be like that. Okay. Let's suppose A, B, C, D is your public key, and uh, X, Y, Z is your private key. Okay. So now we have two keys. Okay. So uh, let's come back to this. Okay, now a single account which you have, your account will have two keys, one public key and one private key. And this is our env file, which have four secrets. Okay, so uh, our system is basically zero knowledge system. This is what is a zero knowledge system? Zero knowledge system is a system in which your server doesn't know what your secrets are, uh, even not basically uh, the whole process. In whole process, your env will never be exposed to our servers or to our database or anything, any other person. It will be only, it will be only on your device where you have created it. And if you want to share with your friends, that is a totally different thing. But this is what a zero knowledge system is. Our system will never know what your secrets are. Okay. So when you do env push, what it'll do, it'll create for this project A, it'll create a project ID, project A ID. Then it'll further create a wrapper key. So now, so now your project A ID is in a container or a wrapper. Okay. So we encrypt project A ID using this wrapper key. So this project A ID will be encrypted, and then we have the wrapper key to unlock it. Okay. Now we will uh, okay, we will encrypt this wrapper key using your public key. Okay. And now you have this thing. Okay. Okay. So you have a project ID which is used to encrypt each one of your secrets. Okay, each one of your secrets separately. Then what you have a wrapper key to encrypt your project key. Then your public key will be used to encrypt your wrapper key, and then you can only and only unlock, then it will be go to our server, and it will be stored in our database. So is what we have is your super encrypted project key. Okay. And we have your encrypted file, which project ID encrypted. Okay. So now we have two things. uh, Super encrypted project key. Okay. Super encrypted project key. And what else will be will we have is, okay, okay, what else will we have is uh encrypted secrets, is your encrypted secrets. So now what will happen, uh these both things will be uploaded on our server or on our database. And further, and when you try to call it back by store env pull, what will happen on that time is your encrypted secrets and your encrypted super encrypted project key will came to your device. Okay. Now, what happened? This super encrypted project key can only and only unlocked by your private key, or if you have added your friends as collaborators or stuff like that. If you have added your friends like that, so your project ID will also be encrypted with their public key, which is their kind of username. So uh, your encrypted secrets can also be unlocked by their private key. Okay. So think of it like you have a lock, and it consists of two keys, one to lock it and another one to unlock it. The key which is used to lock it is exposed to everyone. No, everyone can see it. But the key which is used to unlock it is secret. Okay. So it is like that. So this was the stuff. This is something which we have like thought it till yet. What else we have thought of? Uh, they are initialization vector. What is initialization vector? It is something which will uh, which will save our cipher code. First, let me explain you what is cipher code. When your keys will be encrypted, it will convert our server, our system will convert that your encrypted, sorry, your environmental secrets into cipher text, which is not readable by human, but it can be, it can be decrypted with like giving it some time, or maybe finding some pattern on that. So to protect that, we give, we give a pointer to each env secret, uh, and it is a vector pointer. Okay, so it changes in some days. So your the main cipher text is changing day by day. So it is very hard to crack a pattern to decrypt it. Okay, so it is something like that. Huh. Okay, what else we have thought of is okay, what is it? It is authentication tag. Authentication tag is used to check whether your uh, how do I explain it? Okay, let me show you. Like ChatGPT gave us a really good answer for that. Uh, okay, like basic. If I try to explain you the basics, authentication tag is used to check whether your file is encrypted or not, or basically your each secret is authenticated or not. It is something like that. But let's see. A short piece of cryptographic data attached to a message or file to verify authenticity and integrity. Okay. Yeah. Okay. So okay, I remembered the example which ChatGPT gave me, which was, it is like, it is a temper seal. Okay. Let me let me verify it one time. Okay. Uh, is it like a temper seal? Yes, authentication tag is type of a tempered seal, like how you receive an Amazon package, and it is sealed with a chit, which is called tempered seal, which is used to verify that if someone has opened your package, then you'll know that this package is already opened, so you'll return it. Okay, or you can think of it as how teachers checks your answer sheet and sign it with her sign or stamp, so that she can verify that she have signed this paper or not. If someone changes something in that paper, teacher will immediately know that this sorry, this answer sheet is changed with some other thing, or like some other type of basically someone has edited it. Okay, so that is what authentication tag is. Then there is checksum, or you can think of it as hash. Okay, it Okay, let's read it. Small digital small digital value, like a unique math fingerprint generated for block data. Okay. Uh, okay. I don't remember exactly what was the use of checksum. Let me see. IV tag. Okay, this is checksum. Out of all ciphertext, stupid question today. Okay, so this is to verify that if you have changed something in your environmental secrets, it will immediately know the hash or the checksum will change, and it will verify from your laptop's hash to our server hash. If both are changed right now, then it will make a new version of your file and it will be like a commit. Okay, so that is what checksum is. Then there is envelope encryption and key rotation. Key rotation is very important. Key rotation is like I have already explained the wrapper key to you. So why we are using this wrapper key? So envelope encryption is an algorithm which reduces the number of times you have to encrypt your secrets or your files or any type of data in your project. If you want to protect it, you'll have to you know like in a project, if you are using encryption, we encrypt data so many times that it is very hard to do it again and again and again. So what it does is will not encrypt the whole key again and again and again. No, we don't do that. What we'll do, we'll change the wrapper key in some or few days, so that the whole encryption, like you don't have to encrypt the whole thing. The security increases because you are changing the wrapper key in of some or few days. And if we revoke someone, like if someone is working with me on this project and he has the access of this project, so eventually his computer knows what my project ID is. Okay. So he can he can decrypt it after, even after when I remove it from our project. Like it is like I can, uh, like he has downloaded the sum of env files, so I can only revoke him. I can't like go to his house and delete the all the files. No, we can't do that. Okay, so what we are doing is we are changing the wrapper key in some of or few days, so that no one can encrypt it if I revoke someone, or it also increases the overall security. Okay. And other thing is like it is reducing the stress or the number of time we have to encrypt each secret. We don't have to encrypt each secret so many times. So this is what an envelope encryption and key rotation is. Like we are rotating keys so that it increases security, like stuff like that, which I already told you. Okay. Okay. Uh, okay, so we have we have spent 30 minutes to just understand the stuff we have done till now. Okay. Uh, one request from so let's continue. Okay. One request from me, please don't Google. I genuinely think you are one session away from investing itself. I'd rather guide you 10% that you have to memorize someone else's. Okay, let's continue. So yeah, if somebody doesn't know what I'm doing right now, what I'm doing is I'm learning with the help of. Wait a minute. Okay. So if somebody doesn't know what I'm doing right now, I'm learning with the help of ChatGPT. I've explained my whole project idea to ChatGPT, and he's helping me to think like to uh, reach those steps which I don't know exists. Okay, like thinking of architecture, how to break a big chunk of like whole encryption into small parts and uh, study with that. So that is something which we will like it'll help us to do. It is very similar to how we used searching like Google search to uh, do stuff till now, but this saves our time, and also it is very good if you are using AI in such a way to learn. Okay, let's continue. Proteins. So it is asking me about the architecture of how keys will work with each other. So project key, wrapper key, or key rotation, and reducing the number of times we have to uh, what we have to do, we have to encrypt the secret secrets. Then this wrapper key will be using public. But the order is backward. Okay, yeah, I explained the opposite of it. What he asked, like the manner of how things works. Okay. Oh, hi Piyush. Welcome to our stream. Thank you so much for joining the stream. So yeah, this is really interesting. Proposed this. Let me ask you a simple question. What does a public key encrypts? Uh, Public key encrypts the wrapper key, which is used for key rotation. Okay, that is one thing. Then this uh, this wrapper key, this wrapper key will do what? This wrapper key will encrypt the project key the project, then project key is save, then project. Okay, then this project encrypted. Okay, then this encrypted. Oh, encrypted encrypted project key will be stored in our database. Without a wrapper key and with a wrapper key, let's test your original motivation. Key is used to for weaves, key rotates. Okay, that's key inside. Wrapper key successfully protects the key. It does not protect the secret. This main wrapper key solves a different problem, not replication. How we protect the by its storing. Okay, just 1 minute. What is story envy? Okay, so like you can revisit the stream, like you can go back to certain time and you can watch the whole thing, but I'll give you like a summary of what story envy is. It is a project which stores your environmental secrets. So like your web development or your any sort of projects which you are building, or even big companies, their whole website or app have some env keys, which is to store their API keys or stuff like that. Okay, so that is very very confidential. If it gets leaked, so the companies might have to face big losses. Okay, so the project I am building is to store that key. There is currently there are some things uh, which do the same job, but they are not as good as this. Okay, so it is very similar to how GitHub works. Uh, yeah, I guess that's what story envy is. Okay, so what I was thinking about a wrapper key is wrong. If uh, if like my friend has already stored my key or has encrypted my project once, he have my project key in his computer, and wrapper key will never be able to decrypt uh, encrypt the project key again. Why? Because he already have the project key in his device, so he can like literally decrypt my whole environmental secrets anytime. So the only solution is to change the project key, but then again it'll have to in we will have to encrypt the uh, whole secret again and again and again. So it is very long process, so we have to fix that thing. Okay. Okay. Mm, it's not wrong. We changed safe. Okay, 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 okay. So what ChatGPT has suggested is very good. So what it is saying is we will encrypt each of the secret. Okay, we will encrypt each of the secrets with its unique encryption key, and that encryption key will be further encrypted with the project key, and then the whole chain will start. So, but my point is like it is very difficult. Okay, let me ask. Uh, isn't it difficult to generate so many keys and keep track of that? Also, uh, if we remove someone from project, will still have to change the keys and encrypt the secrets again. Okay, so there is something which we are doing already, which is creating an manifest file for our env files, so that we can store different versions of it, like production or production.env, or development.env, or stuff like that, or template.env. So we track them. Okay, so we have a certain number of like keys, and then we can create versions accordingly. Okay, so that is one thing why we are then also we are generating authentication tags, authentication tag initialization vectors. So all this stores in your device as a manifest file. So we have to create another section for each key, for their own project ID, project key ID, version, and like status, like what ChatGPT is saying. So so that our server never gets confused what it exactly have to change, and what it doesn't have to change. Okay. Okay, the second option sounds more good. Okay, so Bob leaves immediately. The server blocks all the store env pull, push, or API access to that particular user, which is right now in this case Bob. Okay, then uh, background workers generate second project key, encrypt secrets, upload, and done. But imagine timeline question. Those secrets are still encrypted using key. Evo. Can he decrypt and stole it? Of course, he can stole it because all the secrets are still encrypted using the first key. This it leaves a security window between 10 to 15. There is audit realization. Let me again verify the time windows. Okay, revokes, background job starts, still re-encrypting. Bob, however, gets a copy of encrypted database. Okay, this is called security performance trade-off. Every architecture has trade-offs. You cannot optimize everything. Let's compare. A revoke immediately rotates key, everyone waits. Security is high, but performance is low. Revoke, background rotation. High performance and moderate security. So there isn't a universally correct answer. The right choice depends on the product. Imagine GitHub Boundary repository. Would GitHub make everyone wait? Probably not. They, they enforce it. People immediately perform expensive maintenance. Maintenance asynchronously everywhere possible. Imagine a military intelligence system. Bob leaves. Would they wait even 5 minutes? I think your answer actually very good. Default target startups. I have one. There are there are kind of there are targeting engine and chart able to picture by all the information application and full by the way for you have a complete mental of of a system. Right. Okay, so it is almost the end of our whole encryption algorithm. Like, this is only the second stream, but I am working on this only the encryption part for from like past 10 to 12 days, and it took me so damn time to reach at this point, and still it is very difficult for me to choose one option. Either I can like compromise with security. Either I can compromise with security or I can compromise with time. But if I'll compromise with time, that will you ruin the user user's experience. And if I I don't want to compromise with the security because it, it is environmental secret. It has to be secure. So I'm kind of confused in that particular thing. So what I'm going to do right now is we're going to take a break and I'll think about it for like 3 to 5 minutes and then we'll continue the stream. So yeah, if you want to like if someone is watching, that is. So yeah, if you want to drink water or go to washroom, you can. I mean, I'm no one to stop you anyways, but yeah, let's take a break. Okay, I'm back. Hello, 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 hello. So yeah, Zasperine suggested to think on the stream. So I guess it'll be a good thing to like think on stream. So it is very difficult for me to choose one. But I guess I'm okay with ruining a user's experience because security is more important in this project. A user has to wait for some time if he want full security of his secrets. So I guess I'm going to go with that. If like, what are your opinions? You can also, you know, suggest. So, ruin user experience. I'm starting a poll. Okay, ruin user experience. Compromise with secure. What should I do? Well, honestly, it feels very good. Even like right now, only uh, 4 people are watching me right now, but that number is also like big for me as this is just our second live stream. So yeah, technically it is first because for like the stream before I did before this was uh, unlisted. Yeah. Uh, are you guys even voting or not? I mean, okay, we'll wait for 3 to 4 minutes and then we'll like end the poll. Okay, so uh, कितना ब्लर क्यों लग रहा है? Okay, so like we got two votes on ruined user experience. So yeah, I guess we are going to do that because security is big concern for this project at least. Okay, so let me switch the window. Here we go. Uh, I guess we should go like go with more security. Okay, I'm very bad at spellings, but let's just not focus on that. Not because more secure. What story NV is? Let's think. Rotate steps faster than one. Its secret remains private. Okay, it is it is just like I don't know. I mean, okay. So yeah, we are going with ruining the user experience, and we are going to provide more uh, like more security to users because that is something important. Let's start off. Let's start. Imagine they ask you to exactly this. You would employees use the graphic access will run immediately within 10 to 15 minutes while our background work finishes. If I'm a customer, actually going to choose first. Okay, so our policy will be remove Bob, then generate simple download template secrets. Input, again, I suppose. So this is what will be our new flow. If I revoke someone, then uh, it my CLI will immediately generates a new project key or version 2, and then we will download the encrypted secrets. Then we'll decrypt it using the first key. Then we'll encrypt. Yeah, then we are going to encrypt it using our new key, which is project key version 2. Then we'll encrypt the remaining then after uh, after like encrypting this secrets, will encrypt them for all the users and then upload everything. So now Bob deletes encrypted project. So like will delete the encrypted project which was of original uh, like which was of Bob. Okay, it is kind of like bit of complex, but it is not very much complex. So okay, okay, I can see right now we have 5 users. That is like the most watching I had today. So it will be very good for me if you all will like uh, come to chat and say hello just one time. So yeah. Okay, now I can see more uh, comments. I'm sorry I missed Addy Raptor's uh, comment. The moment I said, like the moment I asked from you to comment, you just left the stream. This is not good. But anyways, let's focus on our work. But I'm still going to challenge you. Suppose that we have project, so many secrets. The re-encryption takes 38 minutes during this. Nobody can pull. That's painful. I think we need a compromise. This is something real system. Mm, okay. So, huh, okay. So it is very difficult. Again, we are on the same thing once again. If we ruin the user's experience, it can be ruined for so long that he'll stop using our application, which is uh, like if we have so many secrets, then it will take so long to re-encrypt everything and then upload it and then delete the old one. So hi Dexter. So it will be very difficult, and it is not very good for user. Like if I think if I am using the product, this product, then like I might not use it again if it is like that. uh, Eddie's feeling will have to be oh, okay. I'm seeing comments translated in English, so it was very funny to read that in English. Okay. Anyways, so I can't think how will be going to do that. Uh, we have to figure out some way we can fix this. Okay. Because I personally don't want to compromise with the security, I guess. That is a very big concern for me, and like that defeats the whole purpose of this project, which is the security of your secrets. Okay, so I guess this is the last thing which we have to do. So and already we have spent like 1 hour and 5 minutes on this stream. So I guess this is it for today, and I'll think about it. What should I do? What can I do? Because it is something which will take time for me to understand, to think how we can solve this thing, this purpose of like this whole problem. How can I solve it? Maybe I'll ask my seniors or someone like that. So yeah. Okay, so guys, that is it for today. Hope you liked the stream, and thank you so much for watching this. This was so good. This is so good experience for me, and I'm not very fluent uh, in English. So I'm also learning with these streams. Obviously, I'm building the project while learning every small thing which we need to build a website or an application. Uh, and also, I'm trying to improve my speaking skills. So thank you so much for watching, and thank you so much, Dexter. So yeah, that is it for today. Uh, Bye bye.